Hello students, today we are going to start by talking about some dice probabilities. In your notes, if you want to label this as 15D, we're going to take a moment and fill out this table, and this will help us to analyze probabilities related to rolling dice. So the way this works is we're going to consider rolling 2 dice, which is what you typically do for most games, whether it's like Monopoly or you're playing, most board games, you end up using 2 dice. I'm trying to think of other games. Let's see, what other games use 2 dice? Risk, I guess you use a little more. So a lot of board games use 2 dice. Monopoly comes to my mind first, but I'm sure you can think of some more. But if you roll 2 dice and you get double ones, those are called like snake eyes, you would roll a 2. You'd get a 2. If you roll a 1 and a 2, you would get a 3. And if you roll a 2 and a 1, you'd also get a 3. So notice there are 2 different ways to roll a 3, but only one way to roll a 2. So you have a higher likelihood of rolling a 3 than rolling a 2. So interesting. And so what I'd like you to do is pause the video for a second and copy the grid down and fill it out. Okay, so hopefully by now you have everything filled out. So I completed the table, and perhaps you've noticed like what came up the most and what came up the least here in the table. Very interesting. If you've ever heard of like a Las Vegas game called Craps, you might have heard of people calling out 7-Eleven. Also, you have the 7-Eleven gas station, but 7 most likely thing to occur. 1, 2, 3, 4, 5, 6 ways to get a 7. You can get a 6 and a 1, 2 and a 5, 3 and a 4, 4 and a 3, 5 and a 2, and 1 and a 6. So many ways to get a 7. Whereas rolling a 2, only one way. Rolling a 12, only one way. So very interesting when you look at all the different ways to roll these different rolls. So let's go ahead and answer the questions that are over here. They wanted to know the probability of getting all these different rolls. And notice here, they want to know the probability of rolling 2 3s. So 2 3s. So rolling 2 3s, the probability of rolling 1 3 is going to be a 3 and a 3, a 3 and a 3. Let's do 2 3s. So you roll 2 dice, you get 2 3s. So a 3 and a 3, I'm going to go to the grid. A 3 and a 3. A 3 and a 3 is right here. 3 and a 3 means you get a 6 in that way. So the probability of rolling 2 3s is just 1 out of a 36. And the way I get that is there are 36 different possibilities in this grid. So 1, 2, 3, 4, 5, 6. 6 times 6 is 36 different possible ways in this grid. 6 by 6. 2 3s is you get a 3 in one roll, 3 in another roll. So if you roll 2 dice, the probability of getting double 3s, which I highlighted right here, is 1 out of 36. Next, the probability of a 5 and a 6. So you roll 2 dice and you get a 5 and a 6. So a 5 and a 6, I'm going to highlight that. 5 and a 6. You have to think about how many different ways you can get a 5 and a 6. Well, you can get a 5 and a 6 here, that's rolling an 11. Or you can get a 5 and a 6 this way here, because picture it, if one of your dice or one of your dies is red and one of your dice is green, you could get one could be a 5 and one could be a 6, and the other one could be a 5 and the other one could be a 6. So there are two different ways to roll a 5 and a 6. So that is going to be 2 out of 36. Or 1/18 when you reduce it. 2 out of 36. So again, you can get a 6 and a 5 or a 5 and a 6. Now, I always do these pretty much with the grid. So I know the grid seems like it's a little extra, but I like it because it really shows me where all these are. Next, for C, it says, what's the probability? Again, you've rolled 2 dice. So look at the entry. It says a pair of dice is rolled. What's the probability that you get a 5 or a 6? Or is a lot less restrictive. You could get a 5 or a 6. So I'm going to kind of get rid of these highlights. And on one roll, you could get a 5. So let me choose blue here. You could get a 5 on one roll. You could get a 5 on the other roll. You could get a 6 on one roll, or you could get a 6 on the other roll. So any of these rolls would work. A 5 and a 1, a 5 and a 2, 5 and a 3, 5 and a 4, 5 and a 5, 5 and a 6. 6 and a 1, 6 and a 2. They just want you to calculate the probability that if you roll 2 dice, one of the dice is a 5 or a 6. So there's a lot of ways to do that. So you roll the dice, you look at the dice, and one of them is a 5 or a 6. So all of what I have highlighted in blue is our possibilities. All of that. So every single one of those is a possibility. And so I have to count up. This is 6 in this row, 6 in this row. So that's 12 so far, 13, 14, 15, 16, 17, 18, 19, 20. So 20 different ways out of 36 to roll a 5 or a 6. And I can reduce that, maybe divide both sides by 4. So that's 5/9. So again, a 5 or a 6. So I could get a 5. Let's say this represents my first roll and my second roll, 5 or a 6. Okay. Then it says at least 1 6. So I roll my dice, and I'm going to get rid of the blue. Get rid of the blue. Get rid of the blue. Delete it. At least 1 6. So when I look at least 1 6, that means one of my rolls could be a 6, the other roll could be a 6, or both rolls could be 6. So I look at, if my first roll, let's say, is in this column, these could be 6s, or these could be 6s, or I could roll double 6s. So this particular roll represents me getting a 1 or a 6, or a 1 and a 6. So I look at my dice, I rolled a 1 and a 6. So that's at least 1 6. This is at least 1 6. This is a 2 and a 6. This is at least 1 6. This is at least 1 6. This is, and this is double 6s. So that's at least 1 6. Here, these are at least 1 6. So all of these rolls are at least 1 6. Here's 6 and a 1, 6 and a 2, 6 and a 3, 6 and a 4, 6 and a 5, at least 1 6. Okay, so if I count it up, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11 out of 36. So all of those are at least 1 6. So this whole grid is coming in very handy because I'm counting at least 1 6. You know, here's 1 and a 6, so I rolled at least 1 6. All right, I wish I was there to answer your questions, but hopefully that is making sense. Okay, next one we have exactly 1 6. So if I look, it's almost the same. It's almost going to be the same. So if I'm going on with my highlighter and I'm highlighting exactly 1 6, this is rolling a 6 and a 1. So that's exactly 1 6. I rolled 1 6, a 6 and a 1. I roll a 6 and a 2. So that's exactly 1 6. 6 and a 3, 6 and a 4, 6 and a 5. I can't highlight this because this is double sixes. This is not exactly 1 6. That's 2 6s. I should change this because my 11's going away. Okay, now this is exactly 1 6. This is a 6 and a 5, 6 and a 4, 6 and a 3, 6 and a 2, 6 and a 1. All exactly 1 6. I can't count the double sixes because that's 2 6s. Okay, so I count 1, 2, 3, 4, 5, so 10. 10 out of 36. And if I divide by 2, that's 5/18. Okay, next, no 6s. So this is going to be a great use of complement. So the complement of no 6s is at least 1 6. So those are opposites. So complement and opposite are kind of the same thing. So I can just use complement. It is 1 minus 1 minus at least 1 6. Because those are opposites. The opposite of no 6 is at least 1 6. So I can just subtract those and I would get 25 out of 36. Or what I can do is count up everything that has no 6s. So if I look at my grid, everything that has no 6s is basically everything that's in this inner white square. So it's basically a 5 by 5 square. Everything that isn't highlighted, also if I would highlight the 12 in green, that also includes 6s. So everything in here, 1 through 5, and then all here. So 25 out of 36 has no 6s. All right, so now we get to why I added everything up. Oh, I need to keep the 11. Oh, here we go. What has a sum of 7? How many have a sum of 7? So this is where adding them up actually helps me. So how many of these have a sum of 7? Well, you can just count up sum of 7. 1, 2, 3, 4, 5, 6. So 6 out of 36 have a sum of 7, which equals 1 6 of the things. How many have a sum greater than 8? Greater than 8. We don't include 8 because it doesn't say 8 or more. It just says greater than 8. So greater than 8, we have 9, 10, 11, and 12. 9. Oof. Let me undo that. Undo, undo, undo. Okay, here we go. 9. I feel like this might be unnecessary, but whatever. Okay. We're highlighting here. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 have a sum greater than 8. 10 out of 36. And if we divide by 2, we get 5/18. There we go. Sum of 7 or 11. Yeah, 7 or 11. Oh, that pesky 9. 7 or 11. Ooh, it wants to get big. So we know we had 6 7s and we have 2 11s. So 6 7s, we can just count those up. 6 7s and 2 11s, so that's 8 are either a 7 or an 11. Just going to leave that. 1, 2, 3, 4, 5, 6, 7, 8. So 8 are a 7 or 11. Divide that by 4. So that's a 2/9. So if you're playing craps in Vegas, 2/9 chance, that's a 22% chance of rolling a 7 or 11. Sum of no more than 8. Well, look at that. Sum of greater than 8, sum of no more than 8. Does that include 8? I believe it does. So we can use the complement. 1 minus 5/18 is 13/18. That's just the opposite. So if it's the opposite, you can use the complement. So here we are. And I have no idea how I would do that without this grid. So a grid is a probability representation. So we have probability representations that help us with calculating probabilities. Again, I always use the grid. I know it might seem simplistic here because it's just adding, but it just helps me to picture all the different rules that are out there. So if we look at a table of outcomes, because we can also gather data in a table, kind of like we did with our probability or our statistics unit, we can have just statistics being answered and organized in a table. So for example, here they asked teachers, probably in college, probably not Brookfield because we don't really have a robust bus system in Brookfield, how they traveled to school. And it has male and female teachers, and then whether they drove a car, rode a bicycle, or rode the bus to school. And so you can calculate, if you randomly selected a teacher, whether they rode a bike or whether they are a female that rides the bus, for example. So this is yet another table that can help you calculate probabilities. So here, if we have the probability of a male who rides a bike, we can look at a male who rides a bike in the table, and we know there's 10 people. But out of how many? What's the total? So the total, we'd have to add up everybody. But it looks like we can do the car total. The car total is 67. The bike total is 15. The bus total is 23. So if we add them all up, you all might want your calculators. If you get one of mine, put it back when you are done. So it looks like our total is 105. So the probability that a randomly selected teacher is a male who rides a bike is 10 out of 105. We can divide that by 5 to reduce it. And we'd get 2 out of 21. Now this one is a conditional probability. So what they're saying here is, what's the probability if she is female, she takes the bus? So this means your denominator is going to be females. So you don't want to have a denominator of 105. The denominator is going to be female teachers. So if you add up the females that were surveyed, it looks like we have 35 plus 13. We have 48 female teachers. So that's your denominator. So you have to pay attention to what your universal set is, what your your total is here. And takes the bus, well, females who take the bus are 13. So of that set of people, so of this row here, 13 out of 48 females take the bus. And then if we go to the next one, the probability that a teacher takes a car. Well, we know 67 take the car because we already added this particular column, 67, and now we're just back in the general pool of people out of 105. So in the general pool, 67 out of 105, I don't believe that reduces. Next one, this one's tricky, is female or takes the bus. So I'm going to highlight is female or takes the bus. I'm going to use highlighter, is female or rides the bus. Now the reason this is tricky is because these can include overlapping sets. So is female is all of these people. All of these people include women. And then these additional people, let me undo that, that was weird, ride the bus. So what you don't want to do is double count females that ride the bus. You don't want to include double count these 13 women that ride the bus. So you're just going to add up the females. We know there are 48 plus the additional 10 males that ride the bus, because you don't want to double count the 13 that are in both categories. And then that's over 105 because we are talking about all of them. So that's going to be 58 out of 105. Okay, so that's where just adding instead of like, you want to be careful not to double count there. All right, I think we are going to skip this one because I fear we're going a little long. Here is your classwork.